Good morning and good afternoon. Welcome back to another episode of Learn with Ryme. I'm Rymer. My students prefer to call me Riley. I'm a heavy equipment technician. I have a very exciting topic I'd like to talk about. I'm very passionate about it. I enjoy electrical work. And today we're going to talk about series circuits, how to solve those series circuits for the young apprentice or the trades journeyman who's forgotten about how to go back to basics and talk about our electrical troubleshooting. This video is intended as a learning resource, mostly for my students, but I like to think that if I can help just one more person somewhere out there, then I've successfully done my job. We're going to get started. Series circuits, we're going to describe the rules, our Ohm's laws and our Kirchoffs laws. That is going to go through and break down how our series circuits work, and parallel circuits. We'll get to that one in another video. But for now, okay, I have with me my written out list of rules. I have over here on this side, a schematic with all my multimeters in place that's going to help me identify the different aspects or voltage drops or amperage draws throughout this circuit. And as we go through, I'm going to populate all of these drawn on multimeters to help solve this equation. Down here, I have my mathematical equation triangle for voltage, amperage, and resistance and their relationship to one another. We divide from the top to the bottom in either quadrant, and we always multiply across. Now I have the different abbreviated lettering for voltage, amperage, and resistance within this triangle. Voltage or electromotive force is where that E comes in. Amperage or intensity, and resistance represented by an omega symbol on that circuit. Let's talk about our series circuit rules. Okay, rule number one, there's only one path for current to flow through this circuit. So I have drawn out here my battery source. That battery source is then going to leave through one available path, and I've drawn 3 resistors in this path with my closed switch integrated into this circuit. So there's only one path for that current to flow. Rule number 2, current is going to be the same at all points in this circuit. The amount of current that leaves the battery is not going to change. If I have whatever my amperage draw from this battery is, we'll say 3 amps. Okay, we haven't done the math yet. We'll do the math and then we'll have the determined amount relative to our resistors. But I'm only going to have a certain amount leave, and that same current is going to return. We can safely say that amperage in our series circuits is constant. Our third rule, the total resistance of the whole circuit is going to be equal to the sum of all of the individual resistors. I have 3 resistors in this circuit, an 8 ohm resistor, a 4 ohm resistor, and a 12 ohm resistor. I like to use easy math, so I go with easy, nice, well-rounded numbers. Okay, that's not always what you're going to see when you're doing these tests live. Our final rule, the sum of the voltage drops across all the resistors will equal source voltage. So that brings me to my next question. What is voltage drop? Okay, the voltage drop, or how I like to phrase a voltage drop, is going to be the amount of voltage or electrical pressure that's used at a given resistor. In this rule, I'm going to have all source voltage used up across all 3 resistors, and that's going to depend on the individual resistance value of those resistors. Let's take a deep dive into this and apply these rules to this circuit. I'm going to apply a voltage. If I have a 12 volt system, my multimeter is going to read 12.6 volts DC. I am aware of that. I know what my open circuit voltage is normally in a system. I like easy math, so I'm going to change that just to an easy rounded 12 volts. That's the amount of voltage I have in this system within my battery pack, my supply voltage. Next, that 12 volts, as my rule number 4 states, all 12 of those volts will be used at the end of this math problem. I have 12 volts applied here. Now, I don't know the only other information I have in this equation is my resistance values. So I'm going to take my rule number 3 and I'm going to add all of those resistance values together. Okay, so total resistance is going to equal 8 plus 4 plus 12 ohms. And these are the 3 values that I'm looking at. My 8 plus my 12 will give me 20, plus my 4 will give me 24 ohms of total circuit resistance. So I know if I have 24 ohms total circuit resistance, I can then use this 12 volts to determine how many amps are going to flow through this circuit. I'll take that 24, I'll divide it into the 12, and that should give me 0.5 amps. Pretty low amperage draw in this circuit. Now with my series circuits, my second rule states that that current value is going to be the same at every point in that circuit. So I can safely say on all my ammeters that I have half of an amp flowing through that circuit. My half of an amp is leaving the battery. That half of an amp is returning to the battery. All current at all points in the series circuit are the same. I can then go and apply how many volts or my voltage drops across each resistor I'm going to see. Simply by going into my triangle, I want my voltage, so I'm going to apply my other two values that I have. I know I have 8 ohms, I have half of an amp of current, and I'm going to multiply across the bottom of that triangle. Should give me 4. So this voltmeter will read 4 volts DC. That's how many volts are being used at that resistor. Okay, we'll go through the rest of those. We'll apply that same amperage draw to our 4 ohm resistor on the far side there. Half of an amp multiplied by 4 ohms will give me 2 volts. Perfect. We'll use the same formula for the third aspect. We have 12 ohms resistance at this third resistor. We have half of an amp. We're going to multiply those across, and I should see a 6 volts DC voltage drop. Now, my fourth rule states that all of my voltage drops should equal source voltage. To double check and make sure all the maths, we're going to add our 6 volts to our 2 volts and add our, 4 volts. And that should give me source voltage of 12 volts DC. 6 plus 2 gives me 8, plus my 4 gives me my 12. That equation has been solved. If you find these videos helpful, you know what to do. Follow along in the next video. I'm going to talk about how to solve parallel circuits. Have a good evening.